So in this presentation we are going to look at how to compute the z-score, or as you might say in the US, the z-score. So importantly, we have to remember that the two key parameters of the normal distribution are as follows. The mean, or I'm going to just call it the normal mean for the sake of clarity, which is denoted by the Greek letter mu, and also the normal standard deviation sigma. Okay. Again, I add in the word normal to the standard deviation just for the sake of clarity. So suppose we were interested in a randomly distributed variable called x. Now this could be x could be the heights of something or the weights of something or some time period, and that suppose we are given specific values for mu and sigma. What we would do then is that for some particular value x x0, or I just add in that little subscript there just to sort of indicate that it's an observed value rather than a variable name. Capital X is a variable name. This is some particular value, for example 1000, that there is a corresponding z-score z0. Now the z-score is the distance in terms of standard deviations that x0 is away from mean mu. So how we would calculate it is this little formula here. Okay. And again, I just added in the subscripts just to make it a bit easier to read and differentiate it from variable names. So this is the formula we're going to use. Let's put it into action now. So suppose x is weights and the mean of x is 1000 kilograms and the standard deviation is 20 kilograms. Compute the z-score for 1050 kilograms and also 985 kilograms. So we got two little examples there. The first example is 1050 kilograms, and those are the values there again. So the z-score is computed as follows. So z equals over 20, we are going to have 1050 minus 1000. That's equal to 50 over 20, and that is equal to 2.5. Okay, there's no units for it, it's simply just 2.5. Not 2.5 kilos or anything like that, it's just 2.5. So in the second, that's the first one, so that is the first answer there, 2.5. And what you would do then is you go to the statistical tables, but we're not going to do that in this presentation. Let's have a look at the second example here. It is 985, so the z-score is 985 minus 1000 all over 20. That's equal to minus 15 over 20, and that is equal to minus 0.75. Again, you might have a look at your tables and not see negative values there, but it is possible to get a negative z-score, and don't worry about it, there's a special rule you can use. So the z-score in this, for this particular case, is minus 0.75. Anyway, that ends